concerns, issues. Okay, signals and systems. Why do we need to learn signals and systems? Okay, any answers? So over here you see it says that signals may describe a wide variety of physical phenomena. So like what? Like voltages, like current. So they give us some information. For example, if you look at this simple circuit, and the voltage across this capacitor will give us information about the voltage. So this is kind of information, so we call it, it could be kind of signals. So VC across the capacitor, Vs, what is Vs? Voltage for the power source we have over here. So again, this one is also signal. It gives us some information. So the patterns of variation over time in the source and capacitor voltages, Vs and Vc over here, are examples of signals. So we study signals because they have some properties. We want to learn about those properties. Why? Because whenever we face with some kind of, like over here for this circuit, some kind of, for example, VC or VS, voltages over here, we want to see what kind of signals we have, and after that, what kind of equations or mathematical equations we can apply to these kind of signals. So for this course, we have two types of signals. One is continuous, another one is discrete. So what is the difference between these two types of signals? Continuous and discrete.
Well, discrete is just like a set of high and lows, while continuous is across the source of, like, I guess like a variable, I guess, voltage in one case.
Okay, what do you mean by discrete time is high and low?
Like it's just specific values over a set of time.
Yes, specific values is a better description for discrete signals. So you can see over here, CTS, continuous time signals. This kind of signals are continuous. It means we have values at every single point of time. For example, now I'm talking and talking for a long time, so I'm giving you energy. So you can have values at each point of time, some values for energy or some values for voltage. So one example is speech signal as a function of time. So if you look at the signal of speech as a function of time, you will have values for each single point of time. And how about discrete time signals? They are defined only at discrete times. For example, the weekly stock market index, the price of car weekly. Weekly, it changes weekly. So it means I have the price for this Saturday and I have to wait for another Saturday. So I have another price for the next Saturday. So in between there is no value. So that's why we call it discrete time signals. So for this course, how to distinguish between CTS and DTS. Okay, we use T to represent time in the continuous time signals, and we use small n in discrete time signals to represent time. So whenever you see t, it means the signal is continuous, and whenever you see small n, the signal is discrete. Another difference is we use parentheses for continuous time signal and we use brackets for discrete time signals. So for example, we have two signals over here. One is x of t or xt, another one is x of n or xn. So which one is discrete and which one is continuous? First of all, you said we have value for xt at every point of t. Second, I use small t. And third, we use parentheses over here. So this is a continuous time signal. But over here, we have discrete. Why? We have discrete values for x. And we use small n and we use brackets. So between 0 and 1, there is no value for x. But over here, if you see between 0 and 1, if you pick up any value for t, we have values for x. So that's why we call it continuous time signal. Okay, after that, you are interested in knowing energy and power. Energy and power. For example, if Vt is voltage across a resistor and It is a current, so resistor with resistance R, what is the power? The instantaneous power is voltage multiplied by the current. So V times I or V squared divided by R. So if we want to calculate the total energy over the time interval T1 and T2. So just pick up a time interval, for example, between T1 and T2 and calculate the total energy over this time interval. So we have T1 integral T1 T2 pt dt. So why did I use integral over here? Why am I integrating?
Because we need the total energy.
What's that?
Because we need the total energy.
Total energy, okay. So because we need total energy, that's why I use integration. Why did I use summation?
Because it's continuous.
Because this is continuous. That's why I use integral over here. So what is P is V squared divided by R. So now, what is the average power over this time interval? If you want to get average, so 1 divided by T2 minus T1, integral of pt dt. The lower limit is T1 and the upper limit is T2. So the total energy over the time interval T1 and T2 in continuous time signal xt is defined as this: the magnitude of xt squared dt. So whenever you want to calculate the total energy for continuous time signals over the time interval T1 and T2, use this equation. And if you want to calculate the time average power, so you divide it by 1 divided by T2 minus T1 or the time interval. So again, for discrete time signal, for example, we have x of n. Whenever you see x of n like something like this, you must know this is discrete time signal. Why? Because we use brackets and we use small n. So whenever you see discrete time signals, we use summation. We don't use integral anymore. Why? Because we have discrete values. So the total energy, again, the only difference is we use summation over here, and the time interval is n1, n2. The magnitude of xn squared. And how about the average, the time average power? How do you calculate the time average power for a discrete time signal? What's that, Tyler? Yeah, you have the total energy over here. If you divide it by time, you will get time average power. So what is time now for this discrete signal? Okay, what time interval? Not period, we call it time interval. So what is the time interval now? What is the time interval?
From N1 to N2.
N2, what's that?
From N1 to N2.
From N1 to N2. So I should divide this equation by what? I must divide it by what?
Well, you see I understand the N2 minus N1 part of the 1 over N2 minus N1, but I don't understand where or why the 1 comes from.
Okay, that is the question. Why do we have plus 1 over here? So the time interval is N2 minus N1. So why do we have plus 1?
Because you want the number of values between N1 and N2, and just taking the difference for discrete times doesn't give you one. So you have to add one.
Yes. Alex says that because we want the number of the points or the number of values between N2 and N1. For example, if you have 1 and 10, if you say 10 minus 1, how many points you will get? 9 points, but we have 10 points. It just gives us the interval. We have 9 interval, but we have 10 points. That's why we say N2 minus N1 plus 1. Don't forget this. Okay, for discrete time signal, we divide the total energy by N2, the time interval, N2 minus N1 plus 1. So in many systems, we are interested in knowing the power and energy in signals over an infinite time. So whatever we have studied just was over the time interval. But what if we are interested in knowing in an infinite time interval? So it means t from negative infinity to positive infinity. So we call it energy at infinity. So we use lim when we had this equation before. Now we say from minus t to positive t when t approaches infinity. So we get negative infinity, positive infinity, the magnitude of x all squared dt for calculating energy at infinity. Not at infinity, over an infinite time. So for this is for discrete time or continuous time? Continuous time. And over here we have energy of a signal over an infinite time. We use lim, again, summation from negative n to positive n, and the magnitude of xn whole squared when n approaches infinity. So we'll get this equation. So from here you see Sometimes if xt or xn equals a non-zero constant value for all time, so you have, they will not converge. You will get infinite values for xt or xn. How about time average power over an infinite interval? So this is P infinity. I forgot to put over here. Please write it in my notes. So P infinity is lim t when t approaches infinity, and we have this equation. And for discrete time, we have 2 times n plus 1. Don't forget this plus 1. Okay, from here we get different class of signals. The first class you see, we have finite value for energy, but infinite value for power. So we call this kind of signals, we call it energy signal. For example, we have a signal which is continuous. It has value of 1 between 0 and 1, otherwise is 0. So what is the value for P and E? You calculate the total energy over infinite time interval. You will get 1. But how about P? If E is 1, P is lim E infinity divided by 2 times T. So E is a constant, is 1. So number divided by infinity, how much you will get? 0. So over here, the power is 0. Power infinity is 0. And for the second class of signals, I will explain these class of signals through examples. But just for now, description is like this. So sometimes we have finite average power, but the energy is infinity if power is positive. Okay, calculate xn is 4. Okay, calculate E infinity and P infinity. X of n is equal to 4. So you have a signal which is discrete. X of n is equal to 4. So find E infinity and P infinity. You have the equations. Use those two equations to find P infinity and E infinity. What's the value for E infinity? E infinity is y4. What's the equation? to calculate E infinity. So what is the equation to calculate E infinity? For discrete time signal, use this equation. Okay, so you got 4, 16. It means the answer for this equation will be 16. Yes? Why 16? Justin?
Well, you know that x of n is equal to 4, so the absolute value squared is just 16.
Okay, so you have 16 over here. So summation from negative infinity to positive infinity is 16.
Doesn't that just mean that E is finite?
Yes. E is finite. You have 16 for the magnitude of x squared over here, but summation from negative infinity to positive infinity will give you, it is not finite. It will give you infinity. Okay, so E infinity is infinity if xn is 4. How about P infinity? So it doesn't give you finite value for E infinity, it gives you infinite value for E infinity. How about P? You use this equation to find P infinity. So what is the value for the magnitude of x squared? 16. So you have from negative n to positive n summation 16. So how do you calculate that? Summation from negative n to positive n 16. What is the value for that? 16. Did you study calculus or mathematics 1, 2, something like that? Nope. Yes? Okay. So you have negative n, positive n, 16. It means how many points do you have between negative n and positive n? 2n plus 1. So from here you have 2n plus 1 multiplied by 16 divided by 2n plus 1. So what is the answer for P infinity? The 0? Why 0? Your third year student, electrical engineer, and this is very, very simple math. And I already gave you the answer. What is the reason for that? You're a student now, you have to study now. So you won't get time to study in future. So if any part is difficult, just let me know. Or you ask, go to your instructors, teachers, professors, whatever you call, ask them. So now the simple math, the summation between negative n to positive n, 16. Okay, so you have how many points? This is summation. So you have discrete values. So from negative n to positive n, it means how many values you have, how many points you have. 2n plus 1. Okay, so how many values or how many points? 2n plus 1. Is that clear? Is there any student still doesn't know why plus 1? Be brave. Okay, for example, if I have 10 points, so if I say 10 minus 1, it gives me 9. What is 9? It's in interval between the values. I have 9 intervals, but I have 10 points. That's why I say 2n plus 1, because I need the number of points. Okay, so that's why I say 2n plus 1. So from summation, from negative n to positive n, how many points? 2n plus 1. Because this is summation of 16, so the answer will be 2n plus 1 multiplied by 16. And you have over here 2n plus 1. So you have 2n plus 1 multiplied by 16 divided by 2n plus 1. So 2n plus 1 will cancel out each other. You just have 16. So lim 16 when n approaches infinity. So you don't have n, you just have 16. So p infinity is 16. Clear? Josh? Yes? Okay. The third class, there are also signals for which neither p infinity nor e infinity are finite. For example, xt is equal to t. xt is t. So if you calculate e infinity, you will get infinity. And if you calculate p infinity again, you will get infinity. Any questions? Okay, transformations of the independent variable. We have this signal over here. So what is this signal? Continuous or discrete? This is a discrete signal. So we want to shift it in time. So here we have xn. So over here we have xn minus n naught. N naught is positive. So we call this kind of time shift, we call it delayed version of time shift. Why? Because n naught is positive. If n naught was negative, what would be xn minus n naught? What kind of shifting would you get? To the right or left? To the left, yes. If n naught over here was negative, we had shift to the left. So we call, if the shift is to the right, we call it a delayed version. for this signal, this is a continuous time signal. So we have t, this is t minus t naught. So if t naught is negative, we have an advanced version in time shift. So that's why the signal shifted to the left over here. So we call it advanced. So this is time shift. Any questions on time shift? Clear? So if you have signal like this, xn or xt, and you have xn minus n, and n is positive, shifted to the right. If it is negative, shifted to the left, as you see for this one, because t naught is negative. So we call it delayed version, and this one advanced version. Time reversal. So over here, you see xn. This is a discrete time signal. So when n, the sign of n is reversed. Here is positive, now we have negative n. So the signal is reversed in time over here. For example, from here, 0 to infinity. From here, we call it, for example, we have 1, 2, 3, 4, 5, 6. The values are 1. So now from 0 to negative 6, the values are 1. And these values from negative, from 0, for example, to negative 3, will be from 0 to positive 3. So on and so forth. For the continuous time signal, this is the time reversal. So we have this signal over here. So this value for negative t will be over here, and positive t over here. So we call it time reversal. Questions? The last one is time scaling. This is your signal xt, continuous time signal. So x to t, you have compression. Why do you have compression if you have x 2 times t? Why do you have compression?
Period is 2 pi over at least 6.
What's that?
Period is 2 pi over.
No, we are not talking about period right now. It is one signal you have. And do you see me? Okay. Why is it compressed? In time. How about the amplitude of signal? Is it changed or no? Yes or no? No, why? Yes. So now the amplitude is the same, but you have compression in time. How about t divided by 2? You have expansion. Let me explain it over here. For example, we have x of t or xt like this, continuous time signal. For the magnitude of alpha greater than 1, x 2t is 1 from 0 to 1. The amplitude is 2. The amplitude is 2. How do we calculate that? For this signal, look at, please. Why is it so noisy? Okay. X at 0, what is the amplitude of x at 0? The value is 2. And x at 2 is 2. Is that clear? Okay, for this one. For this function, okay, we want to calculate t at 0. So 2 times 0, we have x0, which is 2. So we say x at 0 is 2. So this is, so for 1 second, 2 multiplied by 1. So we have x at 2, 2. So for t1, we have the value 2. So for x2 times t at 0, we have the amplitude 2, and for 1, we have the amplitude of 2. Otherwise, it's 0. That's why we have compression. So whenever you see t is multiplied by alpha, and alpha, the amplitude of alpha is greater than 1, you have compression. So first step, keep the amplitude same. So we kept the amplitude same and divide the alpha t axis by alpha. So you have 2 over here. Just divide it by 2, you get 1. So from xt to get x2t, first step, keep the amplitude same. The second step, divide this one by alpha, you see over here. So we have 2. So 2 divided by 2 will get 1. Questions? For expansion, the same. So we keep the amplitude same. We have 2 over here, we have 2. So we divide it by alpha. How much is alpha over here? Is 1 over 2, or half. So if you divide this 0 by half, you will get 0. 2 divided by half, you will get 4. That's why you have expansion over here. Clear? Questions? Example. Given the signal xt shown below, find xt plus 1, x minus t plus 1, x 3 times t divided by 2, x 3 times t divided by 2 plus 1. Okay, do it yourself now, please. First, find xt plus 1. Draw xt plus 1. What kind of transformations do we have over here? For time shift. Okay, yes. So because one is, we say that t minus 1, because we have negative 1, so we shift to the right or to the left. We shift to the left side, so we have an advanced version. So xt plus 1 is xt minus negative 1. So we have negative 1 over here. It is negative, so we have an advanced version. So what kind of transformation? We have time transformation, time shift, right or left, to the right or left, so to the left. Why? Because we have negative 1 over here. So 0 minus 1, we have minus 1 over here. So this 1 minus 1 will be 0. 2 minus 1 will be 1. So we'll get this figure. Question? Okay. X negative t plus 1. Do it yourself. You have to do it yourself, otherwise you won't learn. Negative t plus 1. What kind of transformations do you have over here? You have 1 or 2 transformations. 2. One is, another one is time reversal. So, okay, you know now what transformations you need. Do it now. Okay, there are few ways to get negative t plus 1. I explained 2 ways. Okay, you have xt like this. So first use time reversal. So you have negative t over here. So negative t will be from 0 to 1. Now you have from 0 to negative 1. The amplitude is 1. So from 0 to negative 1, the amplitude is 1. And from 1 to 2, you have this line. So just reverse it. You will get this line from negative 1 to negative 2. So you will get x minus t. And you have over here plus 1. So you shift to right or to left. Left. So this one is shift to right or left. right. Why? Because you first had time reversal. So instead of shifting to left, now you have to shift to right because you use negative t first. You use which transformation first? Time reversal first, and after that you use time shifting. So now you shift to the right. Don't forget this. Another way I put over here. So now the t is changed to negative t plus 1. So t from here, this figure, look at here, is from 0 to 1. You have this line. Now from t is changed to negative t plus 1 from 0 to 1. So you calculate this one, you will get t between 0 and 1. So you have between 0 and 1 this line. And from here, look at here, from 1 to 2, you have this line. So now you have negative t plus 1 from 1 to 2. So if you calculate this one, you get negative 1 and 0. So from negative 1 and 0, you have this slope. So reverse this slope. You had a slope like this, reverse it, and this is the range for the slope between negative 1 and 0. This is the second way. Clear? Do you want me to explain one more time? Clear? Just is that clear? Okay, so you have two ways. If you use negative t first, time reversal, but make sure you shift to right, or you can use this way. Okay, from my explanation, use find x 3 times t divided by 2. So what kind of transformations do we have over here? Time scaling. So what is the first step in time scaling? Keep the amplitude same and divide axis by alpha. So the amplitude is the same. If you have to divide it by 3 over 2. So if you divide 1 or 0, it will be 0. 1 will be divided by 3 over 2 will be 2 over 3. And how about 2 will be 4 over 3. So you get this. So this is expansion or compression? Compression, yes. Because alpha is greater than 1. Okay, for the last one, 3 times t divided by 2 plus 1. Okay, do it. Do it yourself, please. Again, there are a few ways to find this signal. I put just two ways over here. Again, the first step or first way, you see t was between 0 and 1. So now you have 3 times t divided by 2 plus 1 between 0 and 1. If you calculate this one, you will get negative, t is between negative 2 over 3 and 0. So between negative 2 over 3 and 0, we have 1. And for the second line, is between 1 and 2. Now you have 3 times t divided by 2 plus 1 between 1 and 2. So if you calculate this one, you will get between 0 and 2 over 3. So you will get this line. This is one way. Other way, you find xt plus 1 time shift because we have negative, negative 1. So we shift to the left and then use time scaling from here. So keep the amplitude same and divide this one by 3 over 2. You will get this. Questions? Okay. The next property of signals is periodic. Some signals are periodic. So for example, if we have a continuous time signal, xt is equal to xt plus t. What is t? T is the period for the signal. So if I move, for example, for this one, the period is t. If I move from 0 to t, again, I will get the same signal. Or if I move from 0 to negative t, I get the same signal. So this signal is continuous time signal, which is periodic. So we say xt is xt plus m multiplied by t. So n is integer number for all t. Again, in a similar way, for discrete time signal, we have this equation, xn is equal to xn plus n. So this one n, if I move from 0, for example, if the period for the signal is n to n, I will get the same signal. So for example, from here, I move to n, so I will get the same signal, or I move to negative n, again I'll get the same signal. So this signal also is periodic. Practice example 1.4. So another set of useful properties of signal is the signal being even or odd. So either signal is, some signals are even and some signals are odd. So what is the difference between even and odd signals? You studied this before? Nope. Okay. Yes?
Yeah.
Okay, so what is the difference?
Basically, for an even signal, the negative of the signal is equal to the positive, whereas, or I guess the best way to explain is like x of negative t is equal to x of t for an even signal, whereas for an odd it's negative x of, or
And the at negative things,
yeah,
negative
negative
of
x
the
of
signal.
negative t is equal to x.
Yes, that's correct. So for example, if we have a continuous time signal, x negative t is equal to xt, and for discrete time signal, x negative n is xn. So it means this signal or this are even. So you see, even signals are symmetric around vertical axis. So if I move it like that, I will get the same axis. That's why we have this equation over here. And how about odd signal? For continuous one, x negative t is negative xt and x negative n is negative xn. What does that mean? It means signals are symmetric about origin. So it means if I take the signal and I turn it like this about the origin, again I will get the same signal. So that's why we say they are odd signals are symmetric about origin. Origin is this one, 0 for example, okay? So they have always they have 0 value at 0. Odd signals have 0 value at 0.
So not all the odd signals are symmetric.
Yes, symmetric,
All,
how do you say symmetric about origin?
all odd signals.
All. So for example, this one is odd. Why? Because if you, this is the signal is of this one, okay, and this hand is this. So about the origin, if I use it like that, again, I will get the same signal. So for even signal, I can write this equation, and for odd signals, I can write this equation. Why? Because x negative t is equal to xt. So for here we have 2 times xt divided by 2. Again, I will get xt. For odd signals, negative x negative t. So x negative t is negative xt. So negative multiplied by this minus over here will be positive. Again, you will get 2 times xt divided by 2. So you have xt. So these are for continuous time signal, and these are for discrete time signals. There are exponential and sinusoidal signals are very important, and we have studied them. So that's why we are interested in these signals. So I just review because you already know exponential signals. For a continuous time complex exponential signal, we have this signal. So C and A are complex. So if we'll get real exponential signals, if C and A are real, so if A is positive, so we get growing exponential function, as you can see over here. So if A is negative, we get decaying exponential over here for real exponential signals. If A is 0, so xt is constant. Depends on the value of C. Questions? Any questions? Periodic complex exponential and sinusoidal signals. If A is purely imaginary, so we have this function over here. So we call this function is periodic. So if the function is periodic, it means e raised to the power j omega naught t is equal to e raised to the power j omega naught t plus t. So from over here, this part must be equal to 1. Okay, if omega naught is 0, so xt is 1. If it is not 0, the fundamental period of this signal is this, 2 pi divided by the magnitude of omega naught. So again, for sinusoidal signal, we have over here, just review. So what is A? A is the amplitude of the signal, and from this crest to this one, we call it 1 period. So it is 2 pi, it is fundamental period. So 2 pi divided by omega naught. So what is phi? Is the phase angle and units radians, and omega naught is angular frequency, units radians per second, and f is natural frequency, or the number of cycles per second, units hertz, or 1/second. So we already know this function, this formula, Euler's equation, so which relate exponential to sinusoidal signals. So from here we know this equation for cosine. So that's why, because cosine is the real part for this exponential function. So we say a cosine omega naught t plus phi is a times real part of this function, and sine is imaginary part because of this equation. So you have three signals over here, x1, x2, and x3. So omega, you have three angular frequencies, omega 1, omega 2, omega 3. Which one has the largest value among these three angular frequencies? Omega 1, omega 2, omega 3. Omega 1, why? More, it is more, yes, compact or compressed over here. And that if, but which one is the smallest value? Omega 3. When omega 3 is the smallest value, but T3, the period for the signal, has the largest value. Okay, how to find the total energy over one period? So we have the signal for one period. We say from 0 to t naught, we have this function, whole square dt will be t naught. Do you agree with this answer? So we have the equation for E over one period is from 0 to t naught, the magnitude of the signal squared dt. So what is the magnitude of Ej omega naught t squared? What is the magnitude of E raised to the power j omega naught t? What is the magnitude of E raised to the power j omega naught t?
So spherical sine square is equal to 1.
Yes, square root of, the magnitude of this one is square root of the real part square plus the imaginary part square. So it will be square root of cosine squared plus sine squared. So cosine squared plus sine squared is 1. So square root of 1 is 1. So So that's why over here you have 1. That is the reason. So from 0 to t naught 1, we'll get, what is the integral from 0 to t naught 1 dt t naught. So this is the energy, the total energy over 1 period. How about the total power over 1 period? Is energy divided by that time interval. So this time interval for us now is the period for the signal. What is the period? Is t naught. So we have t naught divided by t naught, we get 1 just for 1 period. But we have infinite signals. So for infinite signals, the total energy will be infinite. For 1 period is t naught, but for infinite period, we get infinite value. Is that clear? Okay, that's it for today. Any questions? No questions? Okay, have a great weekend.